Now, what's a Route 53? See, first of all, it is a DNS service. It's a DNS service. DNS stands for Domain Name System. First of all, let's understand what is this domain name system and why do you need the DNS in your infrastructure? Why there's a need for that? See, first of all, what's a DNS? DNS, that stands for Domain Name System. See, what happens is, for example, this is a user. Okay, he wants to browse a website. For example, this is his machine. He uses a browser and looks for facebook.com. Okay. Now behind the scenes, it hits a DNS server. Okay. The DNS servers will take the input from the user and convert it into the IPv4/IPv6 address, and it will hit the exact web server behind the scenes. So the main purpose of the DNS server is that it's a phone book of the internet. What is that? It's a phone book of the internet. What's a DNS server? The DNS server is a phone book of the internet. What is that? It's a phone book of the internet. Why it's called phone book? See, the thing is that, let's imagine you have to dial your friend's number. So you pick the phone, you just go to the contact list, you search for his or her name, you tap on that name. Your phone software is designed in such a way that it will convert that name into the phone number behind the scenes, and you're able to dial in that number. See, we as human beings, our brains are designed in such a way that we can easily remember the names but not the numbers. So if you're given a task to remember 20 different cell numbers, it's a very tough task. But if we are given the task to remember 20 different names, so down the line we can easily recall those 20 names. So we can easily remember the names of people, places, websites, but we are very poor in remembering the numbers. For example, the cell numbers, phone numbers, even the IP addresses. Now the problem is the servers behind the scenes, they don't understand the language that we use to speak or to have the conversation. Right now, I'm using English as a language to speak to you. Some people use French, German, depending upon which language they use. So we use a language to understand, to have a conversation or to interact, I would say that. But the machines, they don't understand English, French, German, Spanish. They don't understand this language. They understand the language of ones and zeros. So these IP addresses are behind the scenes are being broken into ones and zeros. So now the question really is that how you just break the barrier between the human being and the machines. That's the DNS server. It's a translator. You may have seen this thing, for example, that the two different prime ministers or presidents of different countries, they have a meeting, they speak different languages. So they use translators. So they speak, they just have a conversation with or they speak their dialogue, or I would say they pass on the information to the translator, and the translator will translate it to the other language. Okay, so it's a translator. It takes input from you, like facebook.com, google.com, and convert it into the IP address so that you don't have to remember the IP address of the server. You just remember the name, and the DNS server will just find the exact match of that particular website name and convert it into the IP address. So logically, the DNS server is a phone book of the internet. It's the translator. It's a backbone of the internet. Okay. So that's the main purpose of having the DNS servers. Now, these DNS servers, whenever you type in any username, not the username, I'm sorry. Whenever you just type in any website name, the very first thing is that your computer will look into a cache. You may have for example, you browse facebook.com too frequently. So it's stored in your cache. You may have seen this thing. Sometimes you're not getting the internet, but you're able to open at least google.com page because that's been stored in your cache. After that, it will look into the DNS servers that's being owned and placed at your internet service provider. Okay, so your internet service provider will cache the website names and their IP addresses. Okay, so the first thing is your computer system will look into the cache, and after that it will look into it will hit the DNS servers of your service provider. Then it goes through a lot of chain or multiple DNS servers until it finds a match for you. Fine. So that's the main purpose of the DNS server. Now, I discussed this concept on this DNS server, but the main thing is that how does this relate to AWS? It's a very basic concept. We use it on daily basis. How on earth does it relates to AWS? How it is associated to the Amazon Web Services? See, I give a very small example to help you understand this concept. You are running a complete infrastructure on AWS. This is your VPC. So this is your VPC and mobile. Okay, and let's imagine you have these two different. These are your public subnets. Fine. This is your private subnet. Okay. These are your instances. This is your database, the main database behind the scenes in the private subnet. Upon that, you have placed, let me do one thing. So upon that, you have placed a load balancer. Okay. Now, the thing is, the instances in the public subnet will communicate with the database in the private subnet, and you're running a web application. So the external users will type in, for example, www.xyz.com. Okay. .xyz.com. It will translate to the DNS name of the load balancer. And from there, the load balancer will just route the request to the web servers or the instances running in the public subnet. Load balancer never works on the databases. It's mainly used for the web servers. So on the front end, the load balancer will take the traffic and forward it to the instances. Now, this resolution is done by which entity? This resolution. There's a DNS server running over here. They will take the input from the user and translate into the load balancer's DNS name. Fine. That will translate to the load balancer's DNS name. I'm just giving one example. Maybe, you may have a complete infrastructure running, but you want to have the users reach your web application or the website running in AWS using the domains. So basically, your domains traffic is being sent to the infrastructure components of the AWS, and that's being done, or that's being facilitated by the DNS servers. Let's take one more example. Let's go with a simple example. In this simple example, this is not that much complicated. We have the same VPC, let's suppose in California, a single subnet which is associated to one of the availability zones, a single EC2 instance upon which I've deployed a Drupal web application. Now, to this, I've assigned an EIP, the Elastic IP. I want the external users to type in xyz.com, which translates to the Elastic IP address of the instance, so that the users can reach the Drupal web application running upon the instance. This resolution is performed by Route 53 / your DNS service or servers. Okay. So this is extremely important for you to understand that if you want to route or divert your domains traffic to any of the components running in AWS, then you have to depend upon the DNS service. In our case, the DNS service is the Route 53. You can use the DNS service from any other domain provider, GoDaddy. You have multiple domain providers in the market, Bluehost. So AWS, they have their own DNS service. Fine. So I hope that you're able to just understand and comprehend that why you need this DNS service to route your domains traffic to the infrastructure components running in AWS. Okay. Now, why it is called Route 53? So route is for routing the traffic, and DNS uses TCP UDP port 53 to communicate. It uses TCP UDP port 53. That's why they have labeled it as a Route 53 as a service. Fine. That's why they've labeled it as Route 53. Now, the thing is, there are three main functions of Route 53. So before we can just jump forward and start understanding the different components right now, there are basically three main functions. What are they? First one is that it's being used for domain registration. You can buy a domain from them. Like you can buy a domain from GoDaddy, Bluehost, HostGator, the multiple domain providers. Similarly, you can buy a fresh new domain from AWS. So let me show you exactly that how this works for you. So let's imagine, okay, let's do one thing. Let's go to services right now. Let's go to the services, and let's go to, let me just click close. Okay, let me just go to the main page. So I click on the Route 53 that comes underneath or under the networking and content delivery. So I click on Route 53. Now, once I go over there, once I just go to the Route 53 dashboard, you can see the multiple domains. This is how it looks like. Okay, let me do one thing. Let me just sign out and log into another account where I already have a domain that I purchased from AWS using Route 53 dashboard. So let me sign into a different or a separate account real quick. So let me just do that. So I'm just signing in. Okay, I've just signed in. Now the thing is, I just go to the Route 53 under networking and content delivery once again, because right now I'm using a different account. So this is my Route 53 dashboard. Now on the left hand side, you can see that we have the registered domains. I go over there, and this is a domain that I've purchased from AWS using Route 53 as a service. And if I just go to this domain, you can see all the details of the domain. Fine. The main thing is that whenever you buy a new domain from the through the Route 53, you'll get 4 name servers allocated to your domain. I'll discuss the relevance of these name servers afterwards. I'll discuss about these things afterwards, that what's the relevance or the importance of these name servers. Now, for example, I want to buy a new domain. I want to go for a new domain. So I go to the registered domains once again and click on registered domain. Now you have to search for a domain. For example, type in XYZ AWS. Okay, a .com domain will cost me $12 a year. So I click check, and I will see whether this is available. If this is available, I can just go ahead and I can just pay $12 a year price for this particular domain, and I can just go ahead and just start using it. Now, depending upon the type of domain, .com, .net, .org, .co.uk, .info, .de, .caa, .us, .eu, .accounts, .associates, you can buy any extension or any type of domain, and for every type of domain there's a different price tag. Okay, now once I hit check, I can just click on add to cart, and I can just continue and just pay this upfront fee for this domain for next 1 year. Okay, now the thing is that there's an illusion that if you want to divert a route the traffic to the load balancers or instances or the S3 buckets in AWS, you have to buy a domain from AWS. So it's not the case. The answer is no. It's not mandatory. It is not necessary that you have to buy a domain from AWS. It is not that it's not necessary. It's not mandatory. You can buy a domain from GoDaddy, but you can use the infrastructure with AWS, or you can run the infrastructure in AWS, but you can have the domain with GoDaddy. So it's not necessary that you have to have a domain purchased from Amazon Web Services. Fine, it is not important. It's not necessary. So you can buy a domain from AWS. So this is a very important thing for you to understand, that it is available for you to buy the new domains. The next thing that is the second feature of, or the main function of Route 53 is that it is used for the DNS service. What do you mean by DNS service? DNS service is this one. Converting the domains into the IP addresses or other DNS name. That's a DNS service. These two examples are the best examples of DNS service. Takes the input in the form of your domain and convert it into the IP addresses or the DNS name of the resources running in AWS. So it's used as a DNS service. Okay. Now the question really is that how are you going to access it? The answer is you have to go to the hosted zones. So under the hosted zones, you manage the DNS service for your domains. Hosted zone. Now, I will explain you the hosted zone in detail afterwards. But right now, I just want to stress upon the functions of this service. I want to stress upon the functions of this service. Now, the next advantage or the function of the Route 53 is health checking. And based upon that, you can perform the DNS failover. It's used for health checking, and based upon that, you can perform the DNS failover. Right? Let me show you. If I just go back to the dashboard, I go to the health checks. Now you can use the CloudWatch in this case. So Route 53 will work with CloudWatch to monitor the performance of resources, and based upon that, you can perform the DNS failovers. Now you may ask this question, what this DNS failover is? I'll just give you a very small example, and of course we'll have a complete lab session on all the different scenarios and the configuration stuff that I'm discussing with you. So the DNS failover means that, for example, I'm just giving a very small example, and I will show you the deployment part as well. Let's imagine, so let's take a very small example. We have this region in Mumbai, and we have this region in California. So my entire domain traffic xyz.com is being sent to Mumbai. But if just in case Mumbai goes down, I can go ahead and fail over to North California. So my entire domain's traffic will be sent to the North California. This process is called DNS failover. So if Mumbai infrastructure becomes unhealthy because it has failed the health check, then my entire domain's traffic can be sent to the other infrastructure. It can be sent to the other region. So this process is called the DNS failover. We'll discuss that, how exactly this works for you afterwards. We will perform the configuration stuff. Fine. So these are the three main advantages. You can use it for the domain registration. You can use it as a DNS service, and also it's been used for the health checking. Fine. So these are the important points that you have to remember. So as of now, I've discussed pretty much the main theory behind the DNS or the Route 53. So these are things that we have discussed so far. Now, the last piece of information that I'll discuss with you is the hosted zone that comes under the DNS service. So how you configure how you access the DNS service under the hosted zones. Okay, so I start with the hosted zone right now and just give you some insights into some of the important concepts. Fine. So the question really is, what's a hosted zone? What is a hosted zone? It's a container that contains entire information, entire routing information, routing info for your domains and subdomains. It's a container that contains the entire information, routing information for your domains and the subdomains. See, what happens is whenever you purchase any domain from AWS using Route 53 as your service, automatically they will allocate these 4 name servers. Okay, and if you just go to the hosted zones right now and click on this domain, you will see that, okay, let me just delete these 2 things because they are being pre-configured. So what happens is, this is how it looks like. This is the hosted zone. Okay, so what's the hosted zone? It's a container that consists of the entire information about entire routing information for your domains and the subdomains. So you will see that it consists of these things: NS and SOA. So let me explain you exactly what exactly these things mean, because it's very important. These are some of the important concepts. So can you see on the left side NS, where my cursor is? What is NS? So NS stands for name servers. Now these are the actual domain name servers. These are the domain name servers. So AWS will allocate a set of 4 domain name servers that will perform the DNS resolution, or they will take care of the DNS service behind the scenes. They will just convert your domains request or the traffic to the IP addresses of the instances, or the endpoint name of the S3 buckets, or the DNS name of the load balancers. They will do the conversion. So these are the real work hosts. So NS stands for name servers. The next thing that we have is the SOA. SOA stands for start of authority. What do you mean by this start of authority? Start of authority means that it will just point towards primary name server. So it will say that out of all the name servers, which is the primary name server. So if you see this example on the left side, the SOA, which is start of authority, is saying that NS723, which is this one, is the primary name server out of all the 4. Okay. So what's the relevance of primary name server? So the primary name server has following advantages. First of all, it's a master server out of all 4. It will just manage majority of the DNS queries. And third thing is that it will contain the entire read write copy of the hosted zone database. So in a nutshell, the primary name server, which is being pointed towards the start of authority, which is being mentioned or described by the start of authority, is a master server. It will manage the majority of the DNS queries. It will contain the entire read-write copy of the hosted zone database. It will contain the entire read-write copy of the hosted zone database. Fine. So that's the importance of the SOA, or the start of authority, or the primary name server. Okay, so let me just reiterate. NS are the name servers. These are the real work hosts. They perform the DNS conversions. SOA stands for start of authority. Start of authority. It will just point towards the exact main name server, which is NS723, which will manage the majority of the DNS queries. It's a master server in this entire cluster. It will contain the entire read-write copy of the hosted zone database. Fine. So these are the two main things that you have to remember, okay, or recall afterwards, because this is the part of the configuration that you have to look into afterwards. This is the part of the configuration that you have to look into afterwards. Fine. So this is all about the theory on the Route 53. Now I shall start with the demo. See, what I will do is I start with the demo. But before that, there's one more thing I want to stress upon, is that in the hosted zone, you create the record sets. For example, I create a record set on the top. You can see that, create record set. And I can choose, this is my domain name. I can make it as www.learnawsthehardware.n. Now this is the record type. For example, if I choose a record, then I can just convert it into the IP address. For example, I can specify the IP address of the instance that's running in AWS. So I'm saying I create a record set in this hosted zone saying or stating that if someone types in www.learnawsthehardware.n, go ahead and convert it into the IPv4 address of one of the instances running in AWS. Or I can choose quad A, AAAA. This is for the IPv6 address. I can choose canonical name. This is the alias name. For example, I can say learnawsthehardware.n can be converted into www.learnawsthehardware.n. Guys, you may have seen this thing. Sometimes you type a domain name without www and it's automatically converted into the domain including www, because they use a CNAME record behind the scenes. So if you type in, for example, learnawsthehardware.n or facebook.com without www, after that it is automatically translated into www. That domain name. So because they're using a CNAME record. So CNAME is used to convert the domain from one to other domain. Right, so these are some of the record sets or type of record sets, type of records. We use a record, CNAME, quad A, AA, or I can choose alias record and I can just route my domain's traffic to the load balancer. Can you see that? We have the load balancers, CloudFront distributions, elastic beanstalk environments, API gateways, VPC endpoints. So the thing is that basically you use the alias records for the load balancers and for the S3 website endpoints, S3 buckets. If you remember, we discussed about the entire static website hosting on the S3 buckets. So you can route your S3 bucket traffic as if you host a complete static website on the S3 bucket and you want to route the traffic, or you want to link your domain with that website, then you make use of the alias record. Or you want to link your domain with the load balancer, then you can make use of the load balancers over here by choosing the alias targets. We'll discuss the routing policies afterwards, because I'll show you different scenarios where we'll discuss these routing policies in detail. Okay. Now, what I will do is that I'll just go ahead and start with a lab setup. We will just go ahead and start using these things after, or I would say we'll start implementing it one by one. So first of all, before I can just go ahead and start working on in 6 different scenarios. So we'll have 5 or 6 different scenarios for each routing policy. I'll explain you the relevance of each routing policy. So the thing is, the first thing we will do is we'll just set up a lab. So we'll just set up the entire environment. So in this environment, what we're going to do is that we'll pick. Okay, so what we'll do is, first of all, we'll pick Mumbai. So what we'll do is that we'll pick Mumbai and we'll pick California. In Mumbai, I will have a load balancer along with 2 instances. Similarly, I'll deploy a load balancer in California with 2 instances. These instances are similar in nature. They will have the same applications and services running upon them. I'll use a script to install the Apache web server upon these 4 different instances that are scattered in 2 different regions. Of course, they're deployed in the VPC. Fine. So that's my lab setup. So what I will do is that I'll first of all set up this entire environment, and after that we'll just discuss or go through 6 different scenarios, 6 or 5, 6, 7, whatever scenarios we have. Let's make it as 6 or 7. We'll go through 6, 7 different scenarios where I discuss that how exactly you will do the routing or routing of your domain's traffic to AWS in 6 or 7 different ways. First of all, what I will do is I will just go ahead and start doing the deployment stuff. So let me just go back to the services and I go to these 2. So I will just use a script. I will include the script in the resources section, or I will just share with you. So the script that I'll be using would be, let me show you that script. Let me just include that script for you. Hang on one second over here. So let me, this is the script. Okay. Now this script that I'll be using, will install the Apache web application or web server upon instances. I copied this script. I'm sorry. I copied the script. And let me do one thing. Let me just go to the Mumbai's dashboard and I just go ahead and click on launch instance. Now this script will work on only one AMI. That's the Amazon Linux AMI. Click on select over here. I choose my instance type. That's the t2.micro. Click on configure instance details. I pick my default VPC and I pick one of the AZ's AP South 1A. Now this thing I've seen in past 2 days. They've included one more data center, AP South 1C in Mumbai. So I choose AP South 1A, go to advanced details and paste this script. Now in the script, there's an echo command. In this echo command, I can change the text. Just type in, this is Mumbai web server A. Okay, so the same text it would display if you browse this instance using its public IP address. Then I click on next set storage, next set tags. Let's name it and just paste it over here. I click on next configure security group. Now I can just assign any security group to this instance. The main thing is that I should allow the HTTP traffic from anywhere because we would like to browse this instance. So I will allow HTTP traffic from anywhere. That's the main intent. Click on review and launch. I can choose any of the existing key pairs. It doesn't make any difference because we need not log into any of these instances. Click on launch instances and this launches my instance. So I click on this instance dashboard and as you can see that I've just launched this Mumbai web server A. Similarly, I launch another instance with the same AMI, same instance type. This time I pick AP South 1B, shoot back, go to advanced details, and I will just copy and paste the same script. Paste it. So I'll give a copy of the script, and I'll just type in, this is Mumbai web server B. Okay, so I just copy this Mumbai web server B. Click on next add storage, next add tags. I just name it as Mumbai web server B. Configure security group. I pick the same group. Click on review and launch. I choose any of the existing key pairs and launch my instances. Okay, now let's give you a small demo exactly that how it looks like. If I just choose Mumbai web server A and I just copy its public IP and paste it in the browser, you can see the text it displays. This is Mumbai web server A. Okay, so this creates my two different web servers in Mumbai. Now I just go to the load balancers on the left side, and let's do one thing. Let's create a classic load balancer, and let's name it as test ELB, and I just enable the advanced VPC config. I include A and B, which consist of my instances. I'll not change anything else over here. Click on next assign security groups. I just assign the same security group to this load balancer. Click on next configure security settings, configure health check. I keep the same default health check options. Click on next add instances. I choose A and B. Click on next add tags, review and create, and this creates my load balancer in the region of Mumbai. Okay. Similarly, I go to North California. And I go to the instances right now. I click on launch instance. I choose the same AMI, same instance type, t2.micro. I pick one of the AZs, US West 1A, go to advanced details, and I just copy and paste the same script. I change the text over here. This is California Web Server A. Okay. And I just click on next add storage, next add tags. I'm gonna name it as my California Web Server A. Next, configure security group. I just pick any of the groups right now while ensuring that it allows the HTTP from anywhere. Click on review and launch. Launch. I choose any of the existing key pairs and I launch my instance. Done. Then I launch another instance real quick using the same AMI, same instance type. That's a t2.micro. I pick a different AZ this time, US West 1B. Scroll down, go to advanced details, and I copy the same script and paste it over here. Let's type in this is California Web Server B. Fine. And let's do one thing. I just click on next add storage, next add tags. I will just name it as California Web Server B. I just pick the same security group, review and launch any of the key pairs right now, and launch my instance. Now, let's go back. I just go to the load balancers, create one load balancer. I'll pick the classic one. Let's name it as CALELB. And pick my default VPC. Enable advanced VPC configuration. Choose both the subnets. Click on next assign security groups. Pick any of the existing groups. Configure security settings. Configure health check. I'll keep the default health check options. Add the instances, both the instances, and I create the load balancer. So as of now, we have set up a lab environment. We're going to be using 6 to 7 different scenarios to understand different policies and understand how exactly they work for you. So let's understand different scenarios, because we have just set up the entire lab environment where we have deployed one load balancer along with 2 different instances in Mumbai. And similarly, we have deployed one load balancer in North California with 2 similar instances. So we have set up the entire lab. Let's go ahead and start understanding some of the different scenarios and implement those different situations one by one on AWS Management Console. Okay. So what we'll do is that let's go with the first scenario. So I can go scenario by scenario and implement it one by one. So let's get started. So in this scenario one, what we're going to do is, what we will just perform is that this is our scenario one. It's one of the simplest one. So in this simple scenario, what we're going to do is we'll have the VPC. Okay, we have the VPC. Let's pick VPC in North California. Okay. As of now, I only pick only one instance, that is California Web Server 1. Now, what I want to do is that what ability I want to achieve is that the ability that I would like to have is the following. The external user types my domain, learn AWS the hardware.in. So let us make it as xyz.com. Let's imagine. User types this domain on his or her computer. It hits Route 53 DNS servers. Route 53 then converts it to the public IP. I can also assign the elastic IP, it's up to me, but I just go with the public IP, to the public IP address of California Web Server 1, and then Web Server 1, or I would say /a, same thing. And then the user would be able to access the website hosted upon this very web server. Okay, so let's do that. So to implement this scenario, the simplest one, I'm going to just go back to my AWS admin console, and let's go back to this instance dashboard, and let's open the Route 53 in some other tab. Fine. Now what I will do is that I just go to the hosted zones. Go to the hosted zone of my domain, learn AWS the hardware.in. And once I go over there, I create a record set. Okay. And it automatically opens the option on the right hand side. So what I will do is I will say that if someone types in my domain, learn AWS the hardware.in, please convert it into the IPv4 address. Now, underneath we have the TTL, the Stafford time to live. Now the thing is that it's the amount of seconds, or this value determines how long a record set is cached on your computer by your web browsers or the service provider. The lower the value, the faster the changes will be propagated. So I'll just bring it to a minute. Now what I will do is that I will just go to the instance dashboard in California, and I choose California Web Server A, and just copy its public IP. I just go back to the Route 53 hosted zone and paste the IP address of the California Web Server A in the value. Now, the thing is that I choose the routing policy as simple. Now, what's a simple routing policy? Where you don't have any complex routing going on. You just want to divert the traffic to only one single resource. It can be an instance, it can be a load balancer, it can be an S3 bucket, a single resource. So I go with the routing policy, simple, because I just want to divert the traffic to only a single instance. That's it. A single resource. I click create. Okay. Now, if I just type in this, I just try to search this domain, learn AWS the hardware.in. Okay, let me just copy and paste that somewhere else. If let's try some other browser, let me just do that. Just give me a few seconds over here. I'm just trying to open some other browser before I can just try it out. Or I can just try it on Google Chrome. So let me just try that on, okay, let me search on Opera. Okay, it can't be reached. Sometimes it depends upon the service provider, because I've used it multiple times. So let me just do one thing. Let me just turn on my Wi-Fi and just change my internet connectivity. Let me just do that. Just give me a few seconds over here. And I just turn off my present Ethernet connection. Just turn it off. Okay. And I hit refresh. Here we go. Now guys, if I copy and paste the link for you, you can just try it out. Or I would say that as of now, I'm able to access this website. Anyone who has access to the internet, if he or she types in this domain, learn AWS the hardware.in. Anyone can reach this website. What's happening is that the DNS servers behind the scenes, they convert the domain into the IP address of the instance running in North California, and hence you are able to reach this website. Okay, so I hope that this will work for all of you. Okay, so that's about this simplest example that I can give it to you. Okay, so guys, thanks for the confirmation. It's working for all of you. Thanks a lot. Okay, so this is the simplest routing policy. Now let's go with the next one. Okay, so what will happen in the next one is that we will just go ahead and start working on the next concept or the next scenario. So now we'll discuss scenario 2. Now in this scenario, what will happen is that we go a step further. We'll have the VPC in North California, in Northern California, and this is subnet A that belongs to AZA, and this is subnet B. Let's write it down once again. So this is subnet B that belongs to AZB. Okay. Now I have the California Web Server A running in this subnet and California Web Server B running in this subnet. And I have a load balancer in California running on the top of them. Now I want the ability that the external users type in xyz.com. Now if you choose any domain without www, it's called the naked domain name. A naked domain without www. So the user types in xyz.com. This is my naked domain. It hits, once again, it hits Route 53 DNS servers, and the Route 53 will convert it into the DNS name of the load balancer. And eventually, the load balancer will just distribute the traffic to the instances running in different subnets in California. Let's do that. And the routing policy that we're going to choose is simple. That's the routing policy we're going to choose. Why? Because over here, we are just routing the traffic. We are diverting the traffic to a single load balancer. We're not going with any complex algorithms as of now. We are not going with any kind of complex algorithms or complex routing mechanisms. Fine. So let's apply this scenario. So I'm going to go back to the main page, that is AWS Fabric console, and I go to Route 53. I just delete the previous record set to avoid any duplication. I create a new record set, and this time I will convert it to the alias record, which is my California ELB. Routing policy is simple. So I choose the same domain, same target. Routing policy is simple. Click create. And now you just go back to the same thing. It will take a few seconds, and if you just search for the same stuff at your end, let me see if I can just open it on Chrome. So if you just hit refreshes, you may land to a different web page. It will take some time to load up. I think it's been cached on my computer or the service provider. Let me do one thing. If I can just do that real quick, I can just change my internet connectivity and see if it gives me some type of output. Just give me a few seconds over here. Okay, it's still not working. Let me just change my internet connectivity. Yeah, it all depends upon your ISP. So I think it's not working for me as of now. So it's working for a few people out there. I can just try the last time connecting it to my cell network, my mobile network, to this iPhone. Let me just do that real quick. Hang on one second over here. Let me just turn on this thing. Okay. I just try to. So you'll be using the same site. You'll be using the same site. As I change my internet connection, you can see that I'm going to A and B, A, B, A, B. I refresh it. I go to different websites that are hosted, or different web pages that are hosted on different instances. Yeah, it's working for all of us. Fine. So that's great. So I hope that we understood this example, that how you can make use of the simple routing policy to divert or route the traffic to a group of instances that may be running in separate AZs, and the load balancer will eventually take on the domain's traffic and distribute that traffic to a group of instances that may be running in separate zones. Fine. So this successfully completes our second scenario. Fine. Let's go with the third scenario. Let's understand the third scenario. This is scenario 3. In the third scenario, we're going to go a step further, and we will go with the latency-based routing. So the routing policy that we choose is latency. What do you mean by that? See, right now, I have two infrastructures running. If I just try to break it down in a very simple way, we have two infrastructures running. One is in Mumbai, and the other one is running in Northern California. We have two infrastructures running. Fine. We have two infrastructures running that are duplicate in nature. Now, depending upon the user location, for example, this user right now, he is from, let's imagine, Singapore. Or maybe China. Okay. He types in xyz.com. The xyz.com hit the Route 53 DNS servers. Now, it will do some calculations behind the scenes and calculate the latency. For example, for Mumbai, the latency comes out as 20 milliseconds. For North California, it's almost 5 times 100 milliseconds. And it makes sense because Mumbai is near to Singapore and China as compared to Northern California. So whichever latency or whichever infrastructure gives the lowest latency, that would serve the content to that user. That's the latency-based routing. Depending upon your location, whichever infrastructure or the web server will give the lowest latency will be used to serve the web page or the content to that user. Okay. So how you go about doing that? So basically we have to create two record sets, one for North California, other for Mumbai, and the routing policy that we will be using would be the latency based routing policy. So what I'll do is that I just open this page, management console, and let's do one thing. Let's delete the previous record set, and we just create a new record set right now. This record set will just forward the traffic to the Mumbai's load balancer. So I choose Mumbai load balancer right now. In the routing policy, I will choose as latency. I choose the region. So what's the name, special name for Mumbai? That is the AP South 1. AP South 1. That's the one that I choose. So I'm saying this is my domain, learn AWS the hard way.in. I choose the alias record and choose the Mumbai's load balancer. Routing policy, latency, region, AP South 1. That's Mumbai. AP South 1. Set ID, my Mumbai site. And this is just name you assign to it. I'll not associate with any of the health checks. Click on create. Simple. Similarly, I create a duplicate record set by clicking on create record set on the top. I just keep the domain as it is. Choose the alias record, and this time I just pick the California's load balancer. Routing policy, latency. Now for California, the special name is US West 1. You can see that even in the load balancer's name. Let's name it as my CAL California site. Let's do that, and I click create. Done. Now, depending upon your location, if you're near to Mumbai, you'll get to the Mumbai's load balancers and sites. If you're near to the California, you go to the California sites. Now, the thing is, let me just do one thing. Let me switch my connections. Okay. And the next thing I will do is I just hit refresh. Again, because it's picking from this cache, I think I should open a new page and just try it out one more time. Let's give a shot. Can you see that? Since I'm in India, I'm in Delhi, I'm going towards the nearest web server, that's Mumbai. Now, the thing is that you guys are are from different locations. Depending upon your existing location, you'll just either land to the Mumbai's servers or the California servers. But to test it out, I just do one thing. I have a VPN I'm using. It's a Star VPN. Let me just show you right now. So I'm using a VPN. Now, if I use this VPN, we may lose the connectivity for a few seconds, because once I turn on the VPN, we may lose the connectivity. Okay, I just want to show you. So right now, I'm in India, but let me pause. So since I'm in India, I am landing to the Mumbai's web servers. Now I open my VPN and I connect from United States. I pose as a US customer. I choose United States and turn on the VPN. Now, I hit refresh. Now, can you see that once I switched I connected from US servers. I straight away went to the California web servers. And I had just disconnected. I had just disconnected the VPN. Now, if I hit refresh, I will straight away go to the Mumbai servers. Let me connect to the VPN once again. So I connect to the VPN. Here we go. And can you see that? So once I connect to the VPN, to the US based servers and pose as a US customer, I straight away go to the California load balancer. Once I disconnect, then I go straight away to Mumbai. Fine. So this is how exactly this works for you. Depending upon your location, it will just do some calculations, and it will show you the web page depending upon the location and the web server location. Basically, it will just calculate the latency. Whichever infrastructure gives you the lowest latency will be chosen to serve you the content. Fine. Okay. Now the next stuff we'll discuss is the weighted routing policy. So let's discuss this one. Okay, let's discuss that. So next thing so this is the third scenario that we discussed. Let's go with the fourth scenario. So what's that? In the fourth scenario, what we're going to do is that we're going to be going for the weighted routing policy. Now, what we're going to do is over here that weighted means that you assign the weightage to different set of infrastructures or components. For example, I can say that users, these are my users. Their queries are being sent to Route 53 servers, and 50% of traffic is sent to Mumbai, and rest 50% is sent to Northern California. So I can set the weightage. Okay, this is called the weighted routing policy. What is that? This is the weighted routing policy. Now we can't test it as of now, but I show you that how you configure it. So I just go back to the main page, and I just delete the previous record sets. I create a new record set. So let me just click on this create record set on the top, and I just keep this thing as it is. I choose the alias record and choose my Mumbai's load balancer. Routing policy, weighted. Weight, I choose 50%. Set ID, just type in Mumbai site. Okay, so I'm saying 50% of the entire traffic should go to Mumbai's load balancer. This one. Click create. Now I just create a duplicate record set. And this one would be for, so I choose alias record, choose California's website, California's load balancers. A load balancer, I would say that. Routing policy or routing policy, what would be that? Weighted. I just assign the weightage of 50%. Set ID, CL California site. And that's it. Click create. Now we can't test it as of now, but it will just do some calculations, and 50% or half of the overall volume of the traffic will go to Mumbai, and rest half will go to California. So you assign the weightage to different set of record sets. So that's the concept of the weighted routing policy. Fine. That's how you go about doing that. That's how you configure it. Fine. So this completes our fourth scenario. That is the weighted routing policy. Simple stuff. Fine. You just have to see that how it's been configured. Because we don't have any way out to test it, because we have to send a lot of traffic to the load balancers, then we just get the output. But I think you got the essence or the crux of it, that what's the purpose of using this type of policy. Okay. So that's the fourth scenario. In the next scenario, it is quite interesting. In the next scenario, what we're going to do is we will learn about, so what's the scenario 5? We will learn about the geolocation routing policy. So what happens in the geolocation routing policy? Simple. Depending upon your geographical location, depending upon your existing location, you'll be routed to this set of infrastructure or to that particular resource or that region. For example, I would say that if users are coming from Asia, go ahead and route their queries to Mumbai. If the users are coming from North America continent, go ahead and route their traffic to Northern California. Okay. So the Asian users will go to Mumbai. The customers from North America will go to Northern California. Rest will not go anywhere. Okay, this is the geolocation routing policy. Okay, so how you go about doing that? I just delete my previous record sets and I create a new record set, and I would say that go ahead and choose alias record set. The target should be Mumbai's load balancer. Routing policy, geolocation. Location, I choose Asia. So I want to just make this thing available for Asian customers. This should be available for Asian customers. Set ID. Let's type in Asia or Asian users. Okay. So what I'm saying is that this is a geolocation policies. Any user from Asia will be sent to the Mumbai's load balancer in AP South 1. That's Mumbai. Fine. I go ahead and click on create. Similarly, I click on create record set on the top. And I choose the same domain. This time I choose the California load balancer. Let's do that. The routing policy, what I will choose is geolocation. And I choose, let's suppose, North America. Set ID, NA users, North America users. Fine. Click on create. Now the time has come for us to test it out. Now, depending upon your location, if you are from Asia, you just switch over to the Mumbai's load balancer. If you're from North America, you just go to the California's load balancer. If you are from location other than these two different continents, you'll go need not go anywhere. Okay. So since I'm from India, I'm the part of the Asian continent, my queries or my requests are being sent to the Mumbai's load balancer. I'm from India, or any part of a user from any part of any of the Asian countries will be sent to the Mumbai's load balancer. Will be sent to the Mumbai's load balancer. Plain and simple concept. Okay, let's do one thing. Now, I may get disconnected for a few seconds. Once I turn on the VPN, I'm going to pose as an American customer. So I switched my VPN from United States. It's connecting. It's connecting. It's connected. Now I hit refresh. Can you see that? If I disconnect my VPN, I hit refresh, immediately I go to Mumbai servers. Fine. So that's how you go about doing that. That's the geolocation routing policy. Fine. I hope that it gives you the idea that how this works for you. Right. So that's the fifth scenario that we have discussed. That's the fifth scenario. Fine. Now let's go the sixth scenario. In the sixth scenario, it is failover. In the failover routing policy, what will happen? In the failover routing policy, this will happen. We'll take a scenario, we'll just do the implementation in such a way that let's imagine we have two different regions, Mumbai and the other one is the Northern California. Now, what we will do is that this Mumbai is the primary infrastructure, okay, and this is the secondary, or I would say this would be. So this is my okay. So this would be. That means this is the primary. This would be in active mode. And on the other hand, this North California is secondary. This is in standby mode. Okay. Now what happens next? We want to achieve a scenario. If any user types in xyz.com, he should always land to Mumbai's infrastructure. Now, apart from that, I configure the CloudWatch in such a way, we configure the CloudWatch in such a way that if a user types in xyz.com, of course, it will land to Mumbai. But this CloudWatch will analyze the performance of this infrastructure. It will analyze the performance of this infrastructure to ensure that if Mumbai goes down, then it can just work with Route 53 to perform some certain important actions. Okay. Now, in a normal situation, user types in xyz.com, it always goes to the Mumbai's load balancer. What if Mumbai goes down? The answer is simple. If Mumbai goes down, CloudWatch will declare this as unhealthy. It will just work with Route 53 in such a way that it will perform the DNS failover, and the consecutive request will be sent across to the Northern California's infrastructure. Okay. So this includes an additional configuration. We have to configure the health check. Okay, so we'll make sure that if the primary infrastructure goes down, it goes over to the secondary or the standby infrastructure. This is the failover routing policy or the routing policy. So how we go about configuring that, let me show you real quick. It's an extremely it's only one thing that we have to configure extra, that we have to configure the health check. So how you go about doing that, let me show you. I just open the main page. I just delete the two record sets which we created in the previous scenario. I go with the health checks. I create a new health check. Let's name it as test_health_check. It will ask me that what do you want to monitor as an endpoint. Then I have to give the details of the endpoint. It will ask me that do you want to specify the endpoint by the IP address or the domain name. I choose domain name. And I copy and paste the DNS name of Mumbai's load balancer. So I go to load balancers. I just copy Mumbai's load balancer's DNS name and paste it over here. Port would be 80. Path would be the default web page of the web servers running upon the instances, index.html. Fine. This is the endpoint name. This is the endpoint. This is the domain name of that endpoint because we are using the load balancer. If you choose IP address, then you have to specify the IP address of the instance. If you're going with the instance failover only. But right now, this failover will happen if the load balancer shows the instances out of services. Advanced configuration. Request interval, which is 30 seconds by default. This means that this health check would be repeated after every 30 seconds by default. If I make it fast to 10 seconds, this means that this will be repeated after every 10 seconds. So let's go with the 10 seconds interval. Failure threshold is 3. This means that after 3 unsuccessful attempts, the load balancer or that component will be declared as unhealthy. I just bring it down to 1 so that after 1 unsuccessful attempt or 1 failed health check, the Mumbai's elastic load balancer is declared as unhealthy. I go ahead and click next. Optionally, I can create an alarm. I can just create a new SNS topic, specify my this name, route 53 demo Mumbai, something like that. I specify my email ID. So I would say that go ahead and shoot an email if the state of the alarm is being changed. I click on create health check and this creates my health check. Now let's wait. What it says, it has been created successfully. Now I just got an email. Let me just open this inbox. Just give me a few seconds over here. I just got an email. Let me just open this inbox and let me just show you that email. I just received it. Okay, I just got it right now. I click on confirm subscription so that I subscribe myself. I subscribe myself to the SNS topic and the subscription is being confirmed. I just go back to the Route 53 dashboard. The status is showing unknown because it does not have the sufficient data to give me the output. It doesn't have the enough data points to give me the output. That's fine. After a few seconds, it will show me the exact state. In the meantime, I go to the hosted zones on the left-hand side. I go to the hosted zone and I create a record set. The first record set will be for Mumbai, load balancer. I think I'm on the right place. I think it's loading up. Let's wait for a few seconds because, yeah, I choose Mumbai. Routing policy, failover. Failover record type is primary because the Mumbai's infrastructure is my primary infrastructure. Set ID, primary. Evaluate target health, yes. And do you want to associate that with a health check? Yes. And I select my health check that I pre-configured for Mumbai. So I just repeat the entire configuration. I choose my naked domain name, route it to the Mumbai's load balancer, routing policy failover, set ID is primary because this is my primary infrastructure, and I will associate with the health check that I pre-configured. I go ahead and click on create. Done. Then I click create record set. This time I choose it for California. Routing policy, failover. Set ID, secondary because this is my secondary infrastructure. I will not associate with any health check because I haven't configured any health check for California load balancer. I click create. Done. So if I just go back to the health checks and I hit refresh, you can see that it's healthy. Fine. Now, if I just try to browse this domain, let me just drag and drop this thing over here. Let me just go back and drag and drop this thing over here. If I hit refresh, I'll go to the Mumbai's web servers. And all of you, if you just go to the same website, you will eventually hit Mumbai's web servers by default, automatically. You'll automatically hit Mumbai's web servers automatically. Fine. This is how it will work for you. Now, the thing is, let's do one thing. So I suppose all of you are hitting the same web server. To test the things out, what we're going to do is simple thing. We will eventually just go ahead and stop the instances in Mumbai. So I go to the instances dashboard in Mumbai and stop both the servers right away. What will happen? It will take a minute. So the thing is that the load balancer will take these instances out of service within a few seconds. If we just go and just hit refresh, let's wait for a few seconds and have these instances declared as out of service. Okay, before that, I don't want to make the connection trying to kick in. And let me just close this browser because I don't want the connections to be established as of now to the Mumbai's load balancer. And if I just go to this thing, let's wait. Still showing in service. Let's wait for a few more seconds right now. Let's see if something happens over here. Let's see. Okay, still it is working behind the scenes. Let's wait. Okay, so one instance has been declared out of service, and the same goes with the second one. The same goes with the second one. Okay. Now, the thing is that if I just go to the health check, it will eventually show me as unhealthy. And immediately I received this email. Let me show you that the email it has shot an alarm email to my inbox. Can you see that? And now, if you guys, so thanks for the confirmation. if you just go to the same website now, just go to the same website. Let me just go back once again. That is learn AWS.harvard.in. I hit refresh, and you will see that immediately I'm sent across to the California web servers. Fine. This is how the failover routing policy works for you. That's how you go about configuring it. Fine. So this is the scenario that we discussed over here. Fine. Now, yeah, thanks for the confirmation, guys. It is for the app servers or web servers both, but it's not for the databases. It's for app servers or web servers both, because you route your domain's traffic to the front-end servers, the front-end servers. Okay, so we discussed the 6th scenario. Let's go with the 7th scenario. The scenario 7 is multi-value answer. In this thing, it's the simplest of the entire policy stuff, or the routing policy. The thing is that you for a domain, you have multiple record sets. For example, one for this instance. This is for another instance. I'm just giving an example. You just create multiple record sets, and it will just follow a random process to eventually route your traffic to different instances or load balancers behind the scenes. Okay, so that's why it's called the multi-value answer. You define different values for a single record set, a single domain. So what you will do is that I just go back to this thing, and I go to the hosted zones, and I delete my previous record sets, these two, and I create a new record set over here by clicking on create record set on the top, and I choose okay, so now I not go with the load balancer. Let's go with this thing with instances. Let's go to 2 California instances right now. So let's do one thing. Let's go to the instance dashboard on Northern California. I choose the public IP of California Web Server A. Just go back, and I choose the A record. Bring down the TTL to a minute. Just copy and paste that. Routing policy, multi-value answer. Set ID. Let's type in CAL Web Server A. That's it. Click create. Similarly, I create another record set. So I just go back to the instance dashboard, copy and paste the public IP of Web Server B. So let's go there. Shoot back. Bring down the TTL to a minute. Paste it. Routing policy, multi-value answer. Set ID, California Web Server B. Click create. Now it will eventually just send it will just forward your request to any of the servers. Okay, it will just follow a random process, and you can eventually land to any of the servers, A or B, whatever you want to go for. So basically, you just make the DNS queries redundant in nature, so that if one of these servers goes down, you can also associate with the health check. It will make sure that it can just send your request to other health instances. Fine. That being said, this completes the entire conversation on Route 53. So just to recapitulate the entire thing, what is Route 53? Or what we have discussed so far? Let me just open my iPad screen. So a Route 53 is basically, it is a DNS service. Okay. DNS service means that it takes the input in the form of the DNS name or domain name and convert it into the IP address or the other DNS names. And then we discussed the three functions of the Route 53. Then we discussed about the hosted zone. It's a container that consists of the entire routing information for the domains and subdomains. We have name servers, which are the actual domain name servers. Start of authority, which this gives you the exact primary name server out of all the 4 name servers. Then we discuss 6 different scenarios. In the first scenario, we routed the traffic to only one instance. In the second one, to a load balancer using simple routing policy. In the third scenario, we discuss about the latency-based routing policy. Fourth one, weighted. Fifth one, geolocation. And sixth one, failover. And the seventh one is the multi-value answer. That being said, this completes our entire conversation on Route 53. Thank you so much for your time and patience.